Good evening, everyone, and welcome to another episode of Astropreneur. My name is Liam. Now, tonight we have a special guest, and our special guest is Bill Steele from 3D Chameleon. So, Bill is going to come in and talk about his product, 3D Chameleon, and about how it functions and so on. And we'll learn a little bit about Bill's past, about his experience and his knowledge and so on. So, please feel free to ask questions in chat, and we will get to your questions. Now, before we get started, obviously, I'd like everyone who is out here watching, please hit the thumbs up, hit the like button, hit the share, hit the subscribe, ding that bell in YouTube to make sure you get notified about my future episodes as they come online. So without any further ado, I'll quickly skip over to Bill. So where am I? My mouse has gotten lost. Sorry. There we go. Hey, Bill, how are you?
Good. How are you?
Very good. Very good. Where are you based?
Near Cincinnati, Ohio. I'm actually in Indiana, but near Cincinnati.
Oh, okay. So you're not that far. Not that far. I'm in Michigan, so
we're
nearby.
We're in Michigan.
I'm about 30 miles north of Ann Arbor. You probably know Ann Arbor.
Yeah.
I'm about 30 miles north there. So is where I live in a city called Wixom.
Oh, yeah.
Oh, you know it. Okay, cool.
Yeah.
So 3D Chameleon. Okay, I have to ask, where did you get the name, first of all?
So my partner actually came up with a name. She's very good at things like that and figuring out the proper name for a product like that. You know, a chameleon changes colors, right?
Yeah.
And we're 3D printing 3D chameleon. Why not? So, yeah.
Okay. Okay. That's so. Tell us a little bit about your background, about yourself, and your background.
So, yeah, background, long storied background, but 3D printing background. I actually have been 3D printing or in this industry for, oh my gosh, well over 20 years, maybe even longer than that. Many years ago, I worked at Microsoft, and on one of the projects there, I was actually working on a prototype device, and I needed some components made. And so we shipped out to one of those prototyping houses, quick fab shops, you know, to do all the manual labor. And they sent me these parts back, and I didn't understand how they were made. They were slightly yellow and translucent, and but they were perfect, you know. And I really didn't understand how they were made. So I called the company up and I said, you know, what is this? How did you do this? And they said, oh, it's our new rapid prototyping machine. And I said, I need to learn more about this. You know, can I come see it? And yeah. So that next Monday morning, I was on a plane out to Phoenix, and I visited their shop, and I saw this resin, you know, liquid resin with a laser curing it. Oh my gosh, this must have been early 90s. Mm-hmm. So it's been quite a while.
Yeah, but resin's been around a while anyway. It's one of the first 3D printing materials.
It was the first. Chuck Hull invented it in 1984, 1983, patented, you know, later on. But yeah, that was my first experience. And then later on, I started working on a couple other projects, and I realized that I really needed to use this instead of the other way. So I started getting into, and those were really expensive machines, right?
Yeah.
And then when the RepRap project was founded, I was very early. I built one of the very first RepRap printers, and I have a serial number 54 of MakerBot Cupcake, right? So that's one of the very early machines there.
Yeah.
I actually have a couple of the cupcakes, and the funny thing is at that point in time, the cupcake was really a horrible machine, but it was a really good machine, right? They're nothing like what we have today.
No,
right?
For its time it worked. But, it worked. It didn't work always as seamlessly as we hoped.
Yeah, exactly. But the cool thing was it had a lot of room for improvement. And I actually spent a considerable amount of time developing improvements for that machine. You know, just learning so much, everything that I could. And then eventually I started just designing whole printers. And I retired from Microsoft in 2012, started my own company called Polar 3D with my good friend Ed. we founded that company. We stayed in it for a little while, and then started doing some interesting research in resin printing, and came up with a couple of cool ideas there, and developed it into a demonstration machine that we showed GE. And at that point, GE said, you need to come work for us. And so
we want to sell to you. We don't want to work for
you. we don't. Yeah, that was what it was. But it turns out that's the same thing if you think about it.
Yeah, I suppose it is. As long as if the money's going in one direction, you might as well give it work for them anyway. So
exactly. And when they say, well, we're going to set up this research lab, and you're gonna have all the funding you need to come up with new ideas. It's like, yeah, that's a lot better than having to struggle to figure out where the money's going to come from to fund the idea.
It's nice when someone provides you the ability to go get all the toys you want and play with them and come up with something that we can use.
Yep.
Like that's everybody on here that's actually watching the channel right now. They're all saying, why can't we have a job like that?
Well, there's good to it and bad to it, right? It is a corporation, and we are unfortunately have been hit very hard by the downturn in the airline industry, because GE sells jet engines, right?
Yeah.
And it's kind of hard to sell jet engines when nobody's flying. So
yeah, and since you're talking about you do prototyping with GE, so I'm assuming a lot of what you do design ends up designing systems for that go into engines, right? Are they functional parts, or are they just beta testing, prototyping?
So it's actually across the board, right? Everything that we do is around, GE Additive is a 3D printing company. GE Aviation happens to be our customer.
Yeah,
there are other customers. Yeah, we have other customers, and then what we do is we might develop a printer, we might develop a printing process on an existing printer, or we might develop both of them together to come up with a totally new way of doing something. And we might even say, well, you have a particular product and we can make it better. We can use additive to manufacture it in a different way, more efficient, better, whatever, stronger. And that's what our group does, is we focus on all three of those key aspects of it.
Okay, so tell me a little bit about how you came up with the idea of the Chameleon, because like we've all talked about making our single printer a dual extruder.
Mm-hmm.
We've all talked about doing mixing heads. We've all talked about all of this. How did you go from I have a printer with one extruder and I want to add 2 to I have a printer with one extruder and I want to add 32?
Yeah.
So that's a big leap, right?
It is. What's funny about that is back when I was at Polar, I actually developed a machine. We never released it, but I developed it that we called Polar 13.
Okay.
And then I had a derivative called the Polar 13C, which was color. And it was a polar coordinate printer where the extruders swung on another polar axis. Okay. And initially it only had one extruder, but I realized that there was 2 sides to it, so I could actually put 2 extruders. And I got to thinking about it. It's like, well, there's no reason why I couldn't put 4 or 8 or however many I wanted to on there, as long as they could fit within that radius. So I got to thinking about that, and I developed a 4-color version of the printer just to prove that we could do it. We never decided to actually sell the machine, but I did build 4 or 5 prototypes of it, and really, really nice looking prototypes. I wish I still had that machine because they were gorgeous. So that is kind of what got me started on the color thing. And I worked with MakerBot early on the replicator, which was a dual extruder machine. And that also sparked it. But then when the printers really started taking off, the electronics sat in a configuration that left 4 or 5 stepper motor controllers. Mm-hmm. With 5, you could do 2 colors, right? But most machines only had 4. So you could only ever do 1 color. And one day I was talking with my partner, Dana, and I was discussing this with her, and I said, it's a shame we can't use the axes for some other function when they're not printing. And that occurred is like, as soon as I said that, it's like, well, actually I can do that. So if you look at my very early prototypes of the Chameleon, there's one of them that's great. It's on, literally I'm using the extruder head and I put 2 friction pads and it literally goes and grabs the filament and moves it in the tube. And it has no motors, no anything. It's completely passive, probably cost you all of 50 cents to make. But it worked. It was able to load and unload the stock extruder. And all I did was I used the motors, the stepper motors, the XY axes, to do a second function, when it wasn't printing. And that led me down to another one where I developed a printer bot that had Titan extruders. I had 2 Titans up on top, but they had no motors. Okay. And they were flipped upside down so that their gear drive was exposed downward. And then the print head on the printer had another Titan, which also has that same gear. So what I would do is I would run the extruder all the way to the top of the printer and pick one of those other 2 Titans and mesh the 2 gears together. So when you turn one motor, it also turned the other motor or the other extruder.
Okay.
So
you actually went up to pick up the filament from each one.
Yes.
You used the height of Z to go up and collect it. So you only had one gear, and then the other one had the meshing gear. Pull it in, and then you dropped it off, retracted, and went over and chose the other one as you went over.
That's exactly it. Yep. So again, totally, passive from the point of view of there's no electronics or anything like that, right? And then those were further. There was a whole bunch of iterations, and if you go to my YouTube channel, you'll see a bunch of the old different ones, some gear drive ones, and all kinds of different ways that I was trying it out.
Yeah.
But then I realized that I didn't want to develop an extruder at the time. I thought, well, I'll just use an off-the-shelf extruder. And then I realized that, a side note, I actually wound up acquiring about 25,000 stepper motors, and very cheaply. Well, it doesn't make sense to not use them.
Yeah.
Why not? Because they were very inexpensive. And I thought, well, if I build this Chameleon using a stepper motor, and I developed that little switch that allowed me to select the okay, I don't know what's going on here. Sorry about that.
That's fine.
I have an Apple phone over here that is just going crazy, beeping.
I call them bad apples.
Yeah. So this switch right here literally is just a dual position, dual throw switch. And you take the wire from the extruder.
Yeah.
That normally goes to that, and it inputs here, and then you have 2 outputs. And this switch selects one of those outputs. Okay. There literally is nothing else. There's no active electronics and no passives. It's just a switch. All we're doing is railroad switching, right?
Yeah.
Right. And what I realized is I could use the extruder just to come over and touch the switch whenever I wanted to change which extruder was active.
That's the version of the Chameleon I remember seeing, and that's so when the very first version, because I remember seeing that one. Yeah, and I've known about it for some time, about the Chameleon for some time, but it was that version, and you're thinking about mounting buttons around your printer to make your extruder choices.
Yep. And that's where that 32 extruder limit came in, because if you actually map this out, this one switch would then go to 2 switches. So you can have a left one and a right one, right? To go to one switch or another switch. And it's a binary tree. You could direct which way you could get to it to activate the motor, right? Now, and the 32 limit is because you have a limit of how many of these switches you can mount. You have X, Y, Z, okay, and you can only go so far. So,
yeah.
So that was the old design. Yeah.
There's a question there saying, do you run 2 stepper smoothers?
No. I mean, the stepper smoother would only affect. I mean, this has nothing to do with that. What we do is we disable the stepper driver.
Yeah.
The switch, and then we re-enable it.
Yeah.
So
they say a verb is saying it's genius. He loves it.
Thanks. Yeah, this was the old way of doing it. And the problem with this is that it required that you modify the motor current because those cheap stepper motors that I got.
Yeah.
Well, and I say cheap. They really weren't cheap. They were cheap to me, but they were very expensive, very high quality motors.
They're good motors, yeah.
And I'll tell you where I got them from. 3D Systems had a consumer division that had the Cube 3D printer. I don't know if you remember those.
Yeah, I remember the cubes.
I acquired them from them. So
yeah, they were 1.8 steppers.
Yeah, 1.8 steppers, but they were actually high impedance motors.
Yeah,
compared to the normal stepper motor that we have on it, and they had a reason. But it turned out that high impedance actually works really good for this because if you have two of them activated, you get to a medium impedance. You're still not going to blow your driver out.
Yeah, okay.
So you can have both motors active, and it's still not going to hurt anything. Mm-hmm. Whereas if I tried to do that with a current like the Creality steppers, if you pair two of them up, now you're dropping so low that your motor controller might have troubles with it, right?
Yeah.
So that's the reason why I decided to go with those. That they were not only cheap, but they actually were effective, very effective in working. But it required that you tune the motor current.
Okay. Yeah. I remember because you had to go into the pots and modify the pots.
Yep.
You had to get out your multimeter, so it wasn't really an end user friendly unless you knew your way around a printer and electronics somewhat. It wasn't the most end user friendly solution. Yeah.
So I decided that, well, and then I say Dana decided for me that we were getting rid of that design because she never wanted to touch motor current adjustments again. So
okay, that's a fair point.
So she insisted that I do better.
You don't argue. You do not argue with your better half, right?
Yeah, she's always encouraging me and inspiring me to do better, right?
Yep.
So that's where these new electronics came in, where I decided, well, we'll just put our own stepper controller on there. But the beauty of this is this eliminates so many other problems, right? You don't have to worry about motor currents. You don't have to worry about the how you wire it up. I mean, it says that there's two wires on here and there's two wires on the box, right? Just plug them in, right?
Yeah.
And this is more universal, right? So you don't.
The nice thing is it's got its own stepper motor, so there's no effect on the board. If you need to change a stepper, you plug it off that, you plug in a new one because they are interchangeable, correct?
Yeah. Yep. So it's so much easier to install with this, and the huge benefit is now I only have one switch, right? Yeah. Because what we do is something really cool is that we actually code a sequence of button presses that actually tell it which color you want to go to, right? Mm-hmm. Or whether you're unloading or loading, you're commanding it to the G code is actually doing all the work, sending all the commands to this through no interface other than it touching the switch.
Yeah, an activation, and then everything else is coded internally within the circuit.
Yep. Yeah, there's basically 4 commands that you send this. You want to go to the next color, or you want to go to the first color. Those are 2 commands.
Yeah.
And then there's I want to load or I want to unload.
Which is long retractions, yeah.
Yeah. And that's all done in G code. I mean, literally the G code just goes over and presses the button in whatever sequence it needs.
So a lot of G code, a lot of commands.
Yeah.
Let's say someone wants to turn their. Okay, first of all, is the limit 32 extruders? First of all,
is the limit 32 extruders?
Right. Yes.
Technically, no. That you actually will run out of space on your machine, though. I mean, typically.
Well, that's why we hang them out of the ceiling, right?
If you hung them up on the ceiling, the other problem that you have is the more Y adapters. Our Y adapters are 4-into-1.
Mm-hmm.
The more of those that you have, the longer your retracts, your unloads and loads have to be, right? And you start running into, when you get to 32, you're looking at least 4 levels deep of those.
Yes.
and technically it'll work just fine. It's just slow. It'll be slow.
Like, would you use Capricorn tubing so there's very good tight tolerances, or
you could, yeah.
Okay, Because I was thinking,
but
if
in
you're feeding
reality,
that long and you're feeding it through a long tube, you're going to have some flexure of the material in a standard stock tubing, right? And that's whereas the Capricorn eliminates that because the tolerances are really tight.
So don't forget though that we would actually not recommend you use it as a extruder that way. You would just be loading and unloading, right?
Yes.
So you're going to load into something like a dual geared extruder so that it's actually grabbed locally, right? So you don't want to lose quality in print, right?
Correct.
So you'll actually just use that to load and unload that. That would be all you would be doing.
Okay. So your system has extruders along the top that feed the filament down to the stock extruder. And the stock extruder takes over and actually carries the filament to your hot end. So that's what you tune. Everything else is just G-code moving data, moving strands of material in and out.
Yep.
In the right order.
Yep. Yeah. So you're tuning the length and the speed of.
Mm-hmm.
You basically your stock extruder has to match the speed of the Chameleon, and it'll load and unload. Right. Yeah. We never change our speed. So it's easy for you to tune yours to match our speed, right? That's one of the things that we did. It's counterintuitive until you actually do it, and then when you watch it happen, you say, "Oh, it loads and unloads at the exact same rate."
Loyal is saying you're giving away chameleons to everybody.
No. Loyal. Actually, I hear you're giving them away.
You walked right into that one. So, all right. So we have a lot of filament moving around. So, what is the largest you've ever built?
I built I have a Gigabot, which is a 600 millimeter cube printer, and it has 32 on it. So it has eight of these, two on it's a big box, right? So there's two of these on each side. Hey, Loyal, do you recognize this? You'll have some of these very soon.
So, all right. So how does the G-code side of things work then? Like I imagine there's a lot of G-code commands and a lot of moving around. And I know that like you have your Y adapters, to call them a better term, right?
Yep. Yeah, we call them better. Yep.
Like feeding filament in and out of a bone out of tubing requires the end of the material to be in a shape that will pass through. Yep. So how do you handle that side of things?
So we break it down into steps, and if you want, I can show you the code.
Yeah, sure.
Let me pop over to my machine here. I'll share out Prusa Slicer and show you what that looks like.
Yeah, if you want to share your screen to me, and I'll pop it up for everyone to see.
All right.
Okay, you ready?
Yep.
Okay, there you go. You're on.
So yeah, this is just standard old Prusa Slicer. I haven't upgraded to the final release of 2.3, but it's 2.3 here. And what I have here is, oops.
That's fine. You're still there.
I got it. What I have here is just a machine I'm actually working on right now. It's the Sunlu S8, and I actually added a BMG extruder to it. This particular machine has the Chameleon installed on the top, and it's got Bowden tube to the Y adapter, which the Y adapter is right into the BMG, right where the stock extruder would normally be.
Okay.
And so, and then what I've got here is really the only modifications that we make to the generic Prusa configuration for a machine is that under the general tab, we switch it to however many extruders you have, but we tell it that it is a single extruder multi-material machine. So this would be normally 1 and no check, right? But we bump it up to 4 with a check mark. And then in the custom G code, oh, by the way, in the multi-material mode, we typically set all of these to 0. This last one here, you can actually tune. It's just if you want to load a little bit extra or a little bit less, you can actually tweak that value.
A little extra prime and stuff, yeah.
Exactly, yeah. So, and then all we do is go down to the tool change G code. And in the tool change G code, we do quite a bit. I'm going to scroll real quickly. You can see there's a lot of things going on in here. But it breaks down into some very simple things. the first thing that we need to do is whatever extruder, whatever filament is loaded, we need to unload it. Mm-hmm. And you were talking about the tip shaping, okay? So what I'll typically do is I'll move the extruder to some inert location that's not going to hurt anything. I will generally move it to the other side of the purge block, so away from the part. The purge block will be between this weighting position and the part, right? So that way when we resume printing, if anything dribbles out, it's just going to rub it across the purge block. So that's what this line is.
Okay.
In our kits, we include a section of PTFE tube. It's 1.8 millimeters in diameter. And this is recommended to go either inside the hot end or immediately above the hot end if possible. Okay, and the idea here is that we're going to constrict, and this is really a problem for PLA, but we're going to constrict its swelling and confine it to that 1.8 millimeters. If we can get it to freeze into that size as close as to the hot end as possible, then we know that we'll be able to pull it out through the rest of the system without it tangling or because it's not going to be, it's too swelled up too big that it'll get stuck in some, I'll call it out of spec locations. Some places might be less than 2 millimeters, right?
Yeah, the tolerances will vary depending on the part and what you're using. Yeah.
So we use a special 1.8 millimeter tube for this just to constrict that. And then you can see what I do here is I pull it out of the hot end, 80 millimeters, relatively quickly. And then I slowly move it up an additional 40 millimeters. And this is inside of that 1.8 millimeter tube. So that's going to allow it to slowly cool inside of that tube and freeze to that position. We then do the typical Prusa style ramming, where we take it and we run it all the way down into the tip and back it all the way back out. So here we go all the way to the nozzle and we back it back out, back in and back out. And what this is actually doing is this is eliminating blobs that form on the end of the filament as you're pulling it out. Mm-hmm. So sometimes as you're pulling it, a little section will break off, and you don't want that to be free or attached by a string. So you ram it and get it to affix to the end of the filament. We then move back out into that 1.8 and we do some more constricting, again, allowing it to slowly cool. And what these will then do, the effect of these lines is you actually wind up with a very nicely sized and shaped tip that looks like a bullet, right?
Yeah, at the end of the filament, yeah.
Yep. The other thing that's important in this is that each filament will have its own temperature settings, right? So every filament that you use, you're going to tune it for that particular process so that you don't get stringing. There's a couple different types of stringing that you'll have.
There's a quick question there saying, is that tubing okay with a micro Swiss, since like an all metal hot end, seeing as the PTFE only goes to the top of the cooling block?
Yeah. So what I said just a minute ago actually applies even with that. What you're going to do is you're going to pull it out of the micro Swiss and into that 1.8 millimeter tubing. You want that 1.8 to be as close to the hot end as possible. If it can't be in it, it's got to be the first PTFE tube that's seen by it, right? Now, again, this only applies to PLA. PLA is really the only filament that swells up so drastically when you pull it out. All the others typically will keep their diameters and they won't have any trouble with it. And it's got to do with the speed of the glass transition and where the glass transition is occurring. But yeah, each filament will have its own temperature setting. So you want to make sure you dial those in individually and test them to make sure you're not stringing it.
10 powers and retraction testings and so on for each of those.
Yeah, exactly. Yep. But the really important thing is temperature, interestingly, in this case, because it will create long strings if it's too hot, and it'll create long strings if it's too cold. The hot ones are round and the cold ones are flat. That's the easy way to tell. And there's going to be a 5-degree range or 10-degree range somewhere in the middle where that you're going to find that there is no stringing. Right?
Yeah, the sweet spot. Yeah.
Yep. So anyway, that's what you do there. Once we do that, we then go ahead and retract it all the way back out. In this particular case, this has got that BMG in the classic Ender 3 style position. So there's a few hundred millimeters of PTFE tube between the hot end and the actual extruder because it's a Bowden, right? So this is actually going to back it out 100 millimeters at a time through that Bowden until it exits the BMG extruder. So it's actually pushed out of the extruder. And the nice thing about this is you can go way too far. It's just going to take a little time, but it's always going to position the filament in the exact same location every time because the extruder can only physically push out of it, right? That's as far as it'll go.
Correct, yeah.
The cool thing about that is once it's there, we know exactly where that filament is at. That's how we figure out where the location of each filament is because we can back it out to that location. That's our known point.
Mm-hmm.
So then it's out of the extruder, and we're just going to go press buttons, okay? And so on this particular machine, I have the button underneath the build plate on the y-axis at the very front of the printer. At literally, this printer has a 310 millimeter build area. So this triggers the switch at exactly 310 millimeters. Okay. So this 308 is a holding I call it a holding pattern. It's holding 1 or 2 millimeters short of that position. It moves to that. It presses the button. It waits for 300 milliseconds in this case, and then it backs off the button. That 300 milliseconds is telling it to move to the next color.
So it's a hold. It comes up and it holds against the switch.
Yes, it holds
there for
1/3 of a second.
Yeah, and then backs off again. Okay.
And then it waits 2 seconds for the Chameleon to actually move to the next. It takes a little while for it to move, right? So it waits 2 seconds for that to happen. So that just advanced it 1 color, and it always does it three times because in the BMG style machine or when you're loading a stock extruder, the 3D Chameleon actually has to let go of the filament, right? Correct. And since we have 4 colors, the way we let go is we simply move to the next color. It grabs a hold of the next color. That's not the one that's loaded in the machine, so it's just holding it in place. It's not hurting anything. And that freed up the one that you've actually loaded in the machine to be pulled in and out, right? It basically acts as a tube at that point. Mm-hmm. We press the button 3 times to get back to the active color.
So you go to the active one, to the inactive one, and like you're basically looping around back on yourself is what you're doing.
That's what happens. Every time you press it, it goes, starts off at 1, it goes, the next one is 2, the next one is 3, the next one is 4. If you do it again, the next one is 1. It automatically will cycle back.
It's like it's through the sequence.
Yep. So once we've done that, we then need to tell the Chameleon to what the next step is, and that's going to be telling it to load or unload the filament. Since we're unloading, we're going to press it for, again, press the button, but in this case, we're going to press it for 3.5 seconds. Okay.
Yeah. There's a question here saying, how would you control board processing speed and serial buffer effect for that 300 milliseconds?
I'm sorry, I missed the question.
He said, how would you control board processing speed and serial buffer effect for the 300 milliseconds?
So there is none.
There's none because it's not being done on the board. It's being done by your circuit separately.
That's correct. Right.
Yeah. So it's not actually on the main board at all. It's actually an independent circuit that actually where you activate the button does all of that.
Right. Yep. And we have a large enough margin between these to figure out what the command is. So they're isolated by a large time delta. Mm-hmm. So, for example, that previous one was 300 milliseconds. The next command, which is always go to basically reset to color 1, is a 1 second pulse. So the difference between 300 milliseconds and 1,000 milliseconds is a huge time compared to the computing. Yeah. And the other thing you have to understand is that we're not doing this pause until we actually trigger the button, right? So there is no delay between when these are happening. That's why we have these holding patterns, right? So we know that it's got to that position and it will not actually proceed. If you look at the pause commands, they will not proceed until the buffer's cleared, right?
Yes, because it's a FIFO environment anyway, so it's first in, first out, right?
Yep, exactly. So in this case, we're going to press it for 3.5 seconds. Technically, it's a 3 second pulse, but we want to just be over just a little bit, just to make sure. So 3.5 seconds. Now, what's interesting is if you look at the mechanical design of the Chameleon, it has no idea which way you're loading or unloading the filament. It doesn't care. You're just commanding it to rotate the extruder motor in the clockwise or counterclockwise.
Yeah, positive or negative number. That's it.
Yeah. And so the way we determine the clockwise or counterclockwise is 3.5 seconds is a clockwise, 5.5 seconds is counterclockwise. And if we have all the extruders coming out of one side, that means we actually have to reverse 2 of them. And that's what this next line does. We press the button, we wait for 3.5 seconds, but if we're on extruder 2 or extruder 3, then we wait an additional 2 seconds to get to get it to spin the other direction.
Yeah.
And then we back off the button.
So the direction and everything is controlled by your stepper circuit rather than being done by the board again. Everything's off the board. The board basically says, I'm feeding material when it hits my extruder. Until then, it's not being used.
Right. So, and then now here's where we say, okay, the first one commands it to what direction it's going to go. This is the direction.
Mm-hmm.
The next one is how long is it going to run for? And here's the other nice thing about this is the second button press after that command, it literally is just going to wait for however many milliseconds or seconds you command. It's going to run the motor for that long. So when I go back and repress the button, notice how I'm unloading the extruder, okay?
Yeah.
And then pausing. So what's happening is I'm pressing the button. That's caused the 3D Chameleon's extruder to start turning in the direction that I commanded up above. And I'm telling the stock extruder to also turn, right? So they're both unloading at the same time.
You can, because their timing is the same.
Yes. Yep. And that's again, this speed right here determines that, right? So that 2500 happens to be turning at the same speed as the Chameleon running.
Mm-hmm.
Okay. And then I say, okay, continue to run. I'm continuing to press the button for an additional 8 seconds, which will pull the filament out of the BMG completely and all the way back through the Y adapter and store it up above the Y adapter. So that's how we command it to pull it out.
And that's a measured amount, a measured distance.
Yep. Yeah, and it's you could set it to whatever you want to. I mean, 7 seconds is typically we'll put it right at the top. 8 seconds just gives us a little buffer space.
Mm-hmm.
We then go and switch over to loading. So now we've completely unloaded. Now we'll go back to loading. And here's that 1 second pulse. The 1 second pulse where we're going to tell it to go back to extruder 1. Yep. We don't care where we were at. We're always saying, whatever your previous extruder is, just go to extruder 1 now. And whatever the next extruder is, if it's greater than 1, if it's greater than 2, or if it's greater than 3, we just keep pressing the button, right, to advance.
To jump through that sequence.
Yep, it's cogging it forward to the correct color that you want to choose, right? Again, using that exact same command structure.
Yeah.
Once we've done that, we just give it a pause to wait for it. We then go back into command the motor to turn left or right, right? That's the exact same code as above.
Mm-hmm.
And we then press the button. Notice here we're pressing it for 8.5 seconds. And we're also loading the extruder.
They're both because you're having them both feed forward.
Yep. So this will drive it into the BMG a little bit farther than we unloaded it.
Yeah.
It kind of puts a little pressure on the drive gear.
But then the drive gear gets to bite when it starts turning.
Right, and we're turning them both at the same time, right? So it's like you are manually feeding it. Okay.
Mm-hmm.
Not after 50 millimeters, then we back off of the button. Okay. And that stops the Chameleon from loading. We then press the button 1 time to get off of the active color. Right?
Yep.
So that presses it. We then, from there, the stock extruder takes over. We do the normal load. So we're loading it a few hundred millimeters, and this is where you're going to tune it to get the exact tip right to the filament to the tip of the nozzle where you want it, right? So this last value is what you would tune to get to that.
And you probably want to go over a little bit because you want to do a wipe and a purge before as you do that.
So so the wipe and the purge is actually going to be handled by Prusa Slicer, right? So that's their standard in their print settings. They actually have their wipe and purge settings over here, right? And that's going to still occur independently of what we're doing. We just want to load it right to the tip here. But that's it. We're done. We now tell the user, hey, we've just loaded the next extruder and you're good to go.
So everybody who's out there watching right now, whose eyes have glazed over because they're lost in G code, don't worry about it. This code is already provided by you, and you just with instructions on how to tweak it.
Right.
Your machine.
I actually have lines of arrows that point to it saying, hey, edit this line if you need this, edit this line if you need this, edit this line if you need that. Yep. And what we will do is we will also have example codes for the various machines, and the idea is that we're going to have a library of, so Loyal has, all these Prusa minis that he's going to be adding chameleons to when he gives them away to everybody here, and we'll have the Prusa mini profile, right? So well, actually I have a Prusa mini down here with it on it already, right? So there's known configurations that we'll have. There's going to be some oddball machines that we're going to run into, like the Sunlu with the BMG is not a factory machine, but it's going to be a popular one, so why not? The Prusa Mini with the BMG, same thing, right?
Yeah, and you can customize it. All you have to do is know which part of the code. It's basically measuring from the Chameleon the length to your extruder.
Yep.
And maybe some down to your Y connectors, where you use the Y connector for the shaping and stuff, right?
Right.
But other than that, it's just measurements you have to adjust after that.
Yep. From the Chameleon to the extruder is a time, and from the extruder to the hot end is a millimeters. And
you could actually use a distance as well instead of a time, correct? Because you know how many steps you need, or how many like 50 millimeters you need to move. You could do it either way.
From the Chameleon to the extruder, it's always going to be a time base because you're pressing the button for that amount of time.
Yeah.
Right. But does it come with stickers? Of course it comes with stickers.
Okay, you need to give me, I don't have any of those. You need to send me some stickers. Stickers are always good, right?
Yeah.
So let's see if we have any questions in there. So Dan is asking Loyal when he's going to be giving away chameleons. You started a trend now, you have. Paul said he wants a 256 color chameleon.
So do I.
I think going with the new setup, you can do whatever you want if you get creative enough, I suppose.
I'll tell you what I'm working on, and unfortunately I don't have it in the office here. I have a color mixing machine that has five. It's a five. It's the, what do they call it? The diamond hot end. It has 5 into 1, right? And it's a mixing, and I can put 5 chameleons on it. So that's 20 colors, and you can mix them all with that one hot end.
Moses is saying, with your permission, he'll do a giveaway for a chameleon.
Go for it.
Okay. Dan, can you help me out since you're out there? Can you set up the form and share it? What I'm running this, if you create the form and put it out there, and share the form out and get people to fill in their names, if you don't mind. I'm asking you because I know you've done it on your stream. So, are you willing? Let me know.
Me. I want a sticker for the door. Oh,
yeah.
Yeah, actually, when you buy these, stickers come with it. So yeah, here's a box, and if I open it up, the sticker should be, oh, yep, right there it is on top.
Yep.
So.
Okay, Dan's going to take care of the form, and anyone who's on here can actually fill in the form, and Loyal says he'll take care of it. So name, we need to have an email address, their ID here on YouTube or in YouTube, and they can put in their there are other stuff, and we can do a spin the wheel if you want. If you get it ready, and you can share the link with me, or even I can even if you want, then I can bring you in, and you can share your screen to do a spin the wheel. So let me know.
So, something that we didn't do yet, we actually haven't told them what the 3D Chameleon does.
Yeah. Well,
change it.
There's a lot of conversation, a lot of interest, so it's good that we get. Oh, Lloyd, you're in trouble. You didn't give him a sticker. He says you didn't give him a sticker.
Well, that's not the case, because I know we put one in along with my business card in every box. Yeah. So yeah, we can print in color. There's a video on YouTube in our channel where I actually printed this in real time on when we were doing the virtual East Coast Rep Rap Fest. So that you can actually watch that. That was on a Prusa Mini, printed in Prusa Mint PETG attached. Yeah. That's such a beautiful install on that machine. I love how that it installs on there. Yeah, here's a drawing that our little one did, and this is actually a lithophane.
Oh, a color one, nice.
Yeah, it's color lithophane with Jesse PLA. So that's a real nice one. Actually, I've done a few of those. Those are nice. By the way, point of note: if you're doing lithophanes and you want to show them off and stick them in the window, just be careful, because PLA tends to, when it gets hot,
to
warp a little.
Yeah. So Loyal, there's a question out there. Since you want to do this giveaway, is it US only or what? So and let us know which how you want to handle it. And Dan, I can't seem to be able to mod you. For some reason, when I click on your name, it either gives me the option to time you out. What I'll do is I'll drop you a link so you can come in and join and share your screen and do that kind of stuff. So 1 second. Let me get the link, and I'm going to send it. I'll send it to your Twitter, Dan. So explain to everybody, like, we can do all this filament changes, right? So we can basically do unlimited color changes on any print we want to do, correct?
So not just color, but material as well. If your machine is capable of printing a particular material that, for example, one of the prints, I don't have it with me, but we have prints that have living hinges in it, right? And the living hinge is printed with TPU. And then the parts are, PLA, right? So then you get a flexible part. If you have 4 materials, or if you have 8 materials, whatever it happens to be, or you can do both. You can mix colors and materials, right? So that's.
And this can work with a mixing head. It can work with any of that.
Certainly, yeah. So like the little A10M, for example, it's got dual, and it's got a mixing head on it. What's interesting about that machine is it's not really a mix that I would expect to see. It's actually, it blends the filament, so you get 2 halves of the filament. So
different mixing heads. There's various quality of mixing heads. Some does a really good way of mixing them. Some do a kind of mix them.
Yeah.
Oh, Dan, check your Twitter. I sent you a message on Twitter with a link so you can come into StreamYard and share your screen when you're ready. So, but share the link to me when you're ready.
So this was a 3-dimensional relief map of the United States, and you can see, look how nice the blend is on.
That's well dialed in, yeah.
Yeah, and that was on the Prusa Mini. Little Raspberry Pi case, same concept, but that's actually the top surface instead of the bottom surface.
Yeah. TK, I'll share the link when Dan has it ready. Dan is helping out in the background to set up the form, so I'll share it when it's ready. So, okay, so it'll work for Bowden tubes. Will it work for direct drive?
Oh, sure. I mean, it's designed to work with any machine, right? With the direct drive, what you're doing is you're using the Chameleon to load it and unload it. In fact, the code I just showed you was for a BMG direct drive. Actually, it was for a Bowden tube, but it would be the same except for the distance to unload and load.
It's shorter, yeah.
Right, yeah. And then, as a matter of fact, we have the installation instructions for both. We're kind of going to migrate over to that direct drive scenario. It's recommended everybody use that. That way you don't lose any. some people have for example, the Prusa Mini where they swap the BMG onto it, right? Mm-hmm. In our Prusa Mini scenario, we're actually removing the stock extruder, and we are the replacement extruder as opposed to the BMG. But we're not a dual drive, right? And a lot of people want that for particular materials that they're working with.
Yeah.
So we highly recommend that you actually use it in the loading and unloading scenario, and that way you don't lose any capability at all with your existing machine, right? The one I was working on just a little while ago is the CME CNC EZR extruder. Really nice design, but they have no way of attaching a PTFE tube to it. So I actually have this little adapter that I just designed that allows you to, it fits between the EZR and the motor, but it adds the PTFE tube holder to it, right? So
just so you can, so you have the feed.
Yep. So, and then your Y adapter goes here, right? So it's feeding into this. And this one actually works really nice. It's a really nice designed extruder.
So Dan, you're off to the side there. I'm going to leave you there for a while. If you get the form, paste it and put it into private chat, and I will share it to everybody. It's already done. Perfect. Okay. So, how do you want to do this, Loyal? Do you want to do a question, or do you just want to do a random drawing? If you want to do a random drawing, let's do the random drawing. Let me paste out the link. Guys, go fill out that form. So you can, and by the end of the stream, we will do a drawing. So someone gets a 3D Chameleon kit, and that'll be a two extruder kit.
No, that's a 4 extruder. We only
4 extruders. So you can actually go up to 4 extruders on your single tube, on your single printer that you have today.
The Chameleon is only 4.
I thought they used to give 2 and 4 in the past.
We did in the old version. We had the 2 color because they were independent, right?
Yeah.
The old kit was only 2 colors. If you wanted 4 colors, you bought 2 color kits.
Yes.
And we would put half of a 4 color Y adapter in each box. So the 2 of them would come together to make a 4 color. But in this one, since we still have 2 motors, right? But with this setup, we're using 2 motors to do the work of 4 extruders. So remember that code that was reversing? That's because if you look at this, I've got this extruder motor here. When I put this in correctly, this motor is driving. You can see the drive gears here as well as over here. And as the selector, the motor on this side is called the selector. It actually is driving a cam that moves these back and forth. Okay.
So it chooses where it's coming out then.
Yeah, and there's 2 layers, so the cam is double layered. They're 90-degree offset, so it can actually pick one of 4 locations by doing that, and that actually activates one of the 4 colors, right?
Yeah, that's cool.
So so that you have, with 2 motors on here. Let me grab this other one. So that setup right there is basically the entire thing.
Yeah. It's nice and tidy because the old system was a lot more involved.
Yeah.
But I've seen these before. I've seen your recordings and stuff of this before, but it's changed a lot. It's come a long way from the big buttons, big clunky mechanical buttons that you had to set up to do multiple extruders.
Yeah, so here's the cool thing. I have a new light version coming out soon, which is for Bowden systems only.
Mm-hmm.
This is the old switch from the original Mark I design.
Yes.
This is all of the electronics, the switch, everything. It actually is no switch. It's a Hall effect sensor. This is the entire thing for the new design. So it has the microcontroller on it and everything, stepper motor driver, it's all.
So the Hall effect sensor means there's no more mechanical switch now. Now it's actually a magnetic.
In the light version, there will be a Hall. It comes with a little magnet that triggers this. Yep. And this is it. There's no power. There's no other mounting locations. You put this wherever you want. Extruder comes over with a magnet on it. It just drives by this basically. It senses that, and that's what triggers it.
That's way smaller than, like, as I said, I was looking at doing it in the past and time never got to it, but And like now, even the one you had today is you got your steppers built in, right? In
Yeah.
the past, it was a whole pile of mechanical switches, and they had to be done in sequence to get the right thing to be turned on and off.
Yep.
Because you're opening a whole series of opening and closing circuits.
Yep.
But that's not the case anymore now.
Right. Yeah. These two motors drive these two motors, and it's totally independent of everything else. So
That's
yeah,
very
this
cool.
is our normal version, and then our the next one is. I should say okay. I want to
Let's talk about the future then, right? Since we're there.
about the future. Yeah.
Yeah,
So,
let's talk about where it's going.
okay, I will. I wasn't going to, but I will.
Well, you don't have to give details, right? Because, like, I mean, like a small bit, so people have an idea. Like, it's not the product is not stagnant, right? The product has changed from when I first saw it. It's changed dramatically, and you're talking about even smaller controllers nowadays, which even makes it even tidier and easier to use and easier to set up. So
here's what's funny about it. For the public, we call this the Mark II, right? This new version is the Mark II. Internally, it's Mark 18.
Yeah, probably so many iterations you'd have to go through. Yeah.
The weird thing is these are iterations that we were going to release, not the development versions. These were ones that were fully fledged. We thought and we just decided for whatever reason to move on, and we picked the ones that have the best, and say that's the one we're going to go with. But this is the current electronics, and it is also the next version. We're using the same electronics. Actually, we have many uses for this. We have other products coming out in the future that also use this board. But the idea here is that the current version is a kit, and that narrows it down to a select group of us that can build the kits, right?
Yeah, you have to be savvy.
A lot of people don't want to do that. And our real goal was to be a low-cost, I'll say palette competitor, if you will. I don't really want to. They're doing it a different way.
Yeah, they do film infusion is what they're doing to get the colors. Yeah.
Well, technically we are too, if you think about it. We're just
but they're doing it off the machine. They're fusing it and in the right time, in the right timing, so that while it's extruded.
That's an issue that they have, is the timing.
Yeah,
and that's what I wanted to avoid. I actually have all four of the previous palettes, and you say there's not four. There was the palette plus, and the new palette and palette plus, right?
Yeah.
And I didn't care for that joining. I thought, well, it's nice that you can do that, but it would be better. The farther away the join occurs, the harder it is to get it right.
The timing is has to be very precise. The exact distance you have to extrude and so on. Yeah.
That's the Achilles heel of that machine, because it requires ping pong, and there's all kinds of things that can go wrong there, and do. So I decided that we should do it this way. Anyway, so the next version isn't really any different mechanically. It's that it's pre-assembled, and that's what I'm spending like most of my time to this now is we're addressing some minor quality issues, but we're actually gearing up for a large production run, right? I should say a large assembly run. So we'll be doing an assembly line, and they will come pre-built. That's the big upgrade that we'll have.
Okay, and guys, I've just posted a link again to the form. You need to fill out the form, and we're going. And then I have Dan is actually actually in the background right now, and we're going to fill. If you fill out the form, and at the end we will do a drawing. Loyal has been amazing, as he's always amazing when it comes to streams. But he has actually offered that we're going to do a drawing, and someone's going to get chosen to get a 3D Chameleon kit, so they can actually upgrade their printer to 4 extruders and run 4 colors on a single nozzle setup. So make sure you fill in that form. I posted the link again. Sorry, Dan. Or sorry, Bill.
That's quite all right. So I forget what I was saying. So yeah, no, that is the next one, right? But we're also going to introduce what we're calling the light version, and that's going to use these smaller electronics. It'll only ship with 1 motor instead of 2, because you're going to use your stock extruder motor to do the extrusion side of it, right?
Yeah.
That is going to be more for the maker, and it only works with Bowden setup, unless Well, no,
Okay.
actually, no, it only works for the Bowden setup because you have to use your stock extruder motor, and
Yes. Yeah.
and we have to have the Y adapter in between, so there's no way to not do it that way.
So someone asked about what's your favorite 3D printer?
What is my favorite 3D? I can't discuss that.
Okay, fair enough. Okay, let's do a different
My
spin.
favorite 3D printer is one that you guys have never seen, okay? And nobody outside of our lab has ever seen.
Okay. So it was something that was an R&D machine.
It is an R&D machine that we are actually developing as a future product. So yeah, it's I posted a message. I posted a tweet on at the beginning of the year of there's a I don't want to say too much, but
Okay.
I feel that there is a need for a printer unlike anything else out there. Okay. If you think about Star Trek replicators, right?
Yes.
They can make
nerd. You're asking about Star Trek. Come on.
Yeah. they make whatever you want. And I feel that even an FDM printer like this, I mean, I can make cool things like this, but there's a big difference between this and this, right? Even though it looks like solid colors, the feel of it is different. Or even better, what about something like this, right? And I want a printer that can produce high quality in full fidelity.
Okay.
So,
all right, I can see where I have an idea where you're going with that one, but okay.
I actually have solved the problem.
Oh, nice.
And we will introduce that machine. It will be phased in. I mean, that machine is probably, well, a couple years away, but we have precursors to it coming out very soon. So
okay, so you've heard it here first, guys. Be on the lookout for that. Follow 3D Chameleon on Twitter.
Yeah,
right. Go follow. That's going to be announced.
That we've come up with a new way of printing that will. It's the way that we really haven't seen before. There are resemblances to other types of machines, but this is a totally new way of doing it.
Yeah.
So think about, the way printing is today. What's the best type of printer? Highest quality, if you will. And we think of that as like an SLA printer, right?
Oh, Loyal's changing the giveaway that he's going to want to give away your prototype printer.
Yeah.
And he says he'll take two for himself.
So there is a fundamental issue with this printer, and that is that it's really hard to do the software. There is no existing software that can drive it, right?
Yeah.
And I developed the belt printers, right? And the belt printers are awesome, especially, I mean, I've got my CR30 there, and I've got the iFactory one out here. It's great to see those finally hitting the market.
Yeah.
But you got to understand, I invented that in 2012. It's 2021 now, and these are just now touching the market.
Yeah.
And I don't want to wait a number of years for the software or for whatever to catch up. So we have a new project that we're working on as well that is developing the software also to drive this new printer, and that's a huge undertaking. It's much larger than a simple little demo, right?
Yeah, I'm sure. Yeah.
So actually, somebody just posted a question back there, and I want to ask them. The question was, I prefer FDM over resin.
Yes.
And I want to know why. I know the answer. I personally prefer an FDM style over resin, but I want to know why. And I will tell you why I'm saying this is because I know the answer to that. FDM is clean. Resin is dirty, nasty. If you touch it, it causes a problem. A lot of people have allergic reactions to it. That's one of the biggest issues with it, right?
Mm-hmm.
What if you could get the quality of a resin? Let's just say you're using a resin. What if you could use a resin but not have those issues, right?
Yeah, if you can do a resin without having to handle it and have it clean and cured stuff all in one.
What if the problem is with those is the process is dirty, right? What if the process wasn't dirty? Now I don't have a problem with it, right?
What if you did it all in the same box, so you never expose it until it was cleaned and exposed?
No. So why clean it to begin with?
Okay,
that's the problem. Why is the process dirty to begin with, right? That's the thing we have to think about. Okay,
guys, if you haven't done it yet, I posted the link to the form. Go fill out the form on chat, please. Click on the link, fill it out. We are giving away a 3D Chameleon kit, so you can get a 4 extruder kit for your printer. So if you go fill out the form, we will do a random drawing at the end. Dan is in the background helping out. Thank you, Dan, for helping. And thank you, especially thanks to Moses, to Loyal Moses, who has actually offered this giveaway to us. And as always, Loyal is fantastic to helping out with the community.
Up on the mountain?
Sorry?
Is he still snowed in up on the mountain?
I don't think he's up in the mountain. I think he's actually back. He's out of the mountain now because it's in the winter, I believe. So there's Paul's answer to your question.
Yeah. See, they always go back to the messy part, and that's the thing. That's one of the things. Is this new printer isn't messy. That's
cool. I'm sorry. I'm trying to keep up with all of the questions coming in. There's a lot of questions coming in. Let's see. No super chat here. Sorry, Loyal. I know it's a bad habit. Oh, he is on the mountain. Yeah. I saw he posted a video the other day of him. His wheel is spinning in the snow. So, okay. Quite a different question that I tend to ask other people. What is the last thing you printed? Not testing your machine. You're testing your system. What was the last thing you printed for you?
For me?
That's a bigger question, yeah?
So I printed a peristaltic pump. And it wasn't for me. It was for another printer, a resin printer that we have at work that was it has a part that fails frequently.
Mm-hmm.
They charge you $400 per pop for when these things fail, and we're doing something especially rough with it, and it breaks them very rapidly. And so I designed a new peristaltic pump for it and printed that out.
Cool.
That won't break. So that was a kind of functional thing. I'm printing a bunch of these orange chameleons in PETG, and I'm also printing some for in Joel's High Five Blue Protopos. Look at how gorgeous that is! Isn't that beautiful?
Yeah, it's a nice color, a nice finish.
Layers. That's a Prusa Mark III. Printing those, but this is for Joel. And on a talk we had a while back, or a couple weeks ago, one of his guys won one on the. I think maybe Loyal might have given that one away too. I can't remember, but there was a talk, and I've been printing these. These look really nice. So.
Oh, by the way, TK, thank you. Yes, please, guys, like, subscribe, thumbs up, ding that bell so you get notified when I do my streams again in future. So please show support for the page. Let me see. The streams are coming. The questions are coming in really fast. 17 likes and 31 watching. Come on, guys, hit those thumbs up and hit those subscribes. Come on. You know you can do better than that.
Let's see. What else did I print? I printed. I printed a set of cup holders for my Fiero. So. Oh,
nice. Yeah, they're practical, useful prints. I do a lot of practical prints.
Yeah,
a lot of useful stuff that you can actually use around the house.
Oh, I print things all the time for the cars, for the house. I printed.
I'm the same. That's where I spend all my. That's why I mostly do PETG. I want it to last.
Yeah. And that the cup holders are in PETG. So
yeah. Okay, so let's see. Already subscribed. Everyone's ready to go. I'm going to bring Dan into the conversation because he's going to be doing his screen share. Hey, Dan.
Hey there.
You're on mute. So let's go quickly through, see if anyone has any last questions. I'm going to post the link one last time.
1984.
Fiero, 1984.
Yep. I got the original one. It's got 65,000 miles on it.
Cool.
Nice.
So, guys, I just posted the link one last time.
Yep.
In about 2 minutes, Dan is going to stop you adding content to it, and we will do the drawing. So, any last questions you have for Bill regarding the 3D Chameleon?
Nope, I'm just fingers crossed I win.
Yeah, it's all my car now. It's all original, 100% factory. It is a very early model, 84. So it's the base 4-cylinder, 4-speed. All original though. Absolutely gorgeous car.
Cool. So, are you ready to shut it down, Dan?
Whenever you are, you let me know, and I'll go ahead and click the little button to turn off responses. We won't take any more, and then I'll get the list put in the wheel, and we can bring up the wheel of fish here and have some fun.
Okay, let's lock it down.
All right. No longer accepting any responses. So
if you're not in, guys, you can't win, and you're already late. So before we do the drawing, right?
Mm-hmm.
Special thank you. Well, first of all, for Dan for helping out, but a really special thank you for Loyal, who offered to sponsor a 3D Chameleon kit. And if you came in late, the 3D Chameleon kit, and Bill is the creator of the 3D Chameleon, and it's an ability to add multiple extruders to your printer, and it's really cool. Now I'm going to share your link. Let me see. I have you here. If you go check out the 3D Chameleon website, you get information there. There's also a YouTube channel. A lot of good information. You see it being set up. Bill walks you through the G code, walks you through the setup step by step. It's not difficult. There's a little bit of mentality needed because you have to do some measurements and so on, but it's not that hard. There's a bit of tuning involved, but you should check it out. It's a really cool ability. So let's see. Are you locked down, Dan?
Give me just 1 second here. I'll go full screen with it, so that way it's nice and full, and hopefully people can see it.
Just grab the first names, right? No email.
Yeah, it's the YouTube name. So whatever they put in for their YouTube stream name, that's the name that's up there. So some people do use their full first and last name. So if you put it out there on YouTube that way, that's how it shows up.
And if you're not already liking and subscribing and following Loyal, find Loyal on Twitter, El Moses, and follow him on Twitter because he's doing so much for the community. Let's support the people who are supporting us, right?
Yep.
So are you ready, Dan?
I'm ready, good sir. Bring the screen on in.
All right, here we go. Spin that wheel.
All right, here we go.
Good luck, everyone.
Lucky winner will be me, right? Me?
Is it me?
I put my name in like 5 times. Is it Tripod
Garage?
It's
Tripod's Garage.
Look at that.
Congratulations, man.
He's going to be doing he'll do a video about it. So you'll have a little bit more going on. He'll do a video. I know he will.
Congratulations.
All right.
Yeah, we were chatting with him in the hangout the other day.
Yeah, I was going to say, I know he was around somewhere. So hopefully he shows back up and says something in chat so you know he's here. There he is.
He's there.
All right. Well, I've got his email information. I will forward that to Loyal so that he can get it purchased and then get it sent out. So Loyal, I will send you Tripod's info unless Tripod messages you first and gets it to you. But one way or another, we'll make sure you get what you need to get Tripod cool. his toy.
Yeah, and once again, thank you, Loyal, for helping out and for offering that. That's I don't always have giveaways, but it's nice to have something. And the fact that you just jumped on and you're such a great supporter of the of 3D printing community, it's fantastic. Thank you so much.
Yes, Ryan, it's rigged.
If it was rigged, it'd be coming to me.
Either that or you guys can see clear enough. There was enough people. You can see that my name's not on there 5 times. However, I think maybe I should have.
So
the price is $199.
that's for 4 extruders.
Yeah, that's the only one we sell now.
Yeah, and that comes with all the extruder motors, stepper motors, and everything all in one kit.
Everything you need's installed except for possibly the 3D printed mounts. So, for example, this has a mount for 80/20 frame or aluminum extrusion, and you can print that. Right.
See, if it was fixed, Loyal would be willing his own giveaway.
You know what? If Loyal would feel better and he wants to give away a second one, I'll clear the wheel. We'll put the name back in there and we'll spin it and see if he can win.
Yeah, change them all to Loyal's name and hit spin.
So maybe I'll put Loyal's name in there a few times and I'll just spin it and but yeah, he'd have to agree to the second one though, because I don't want to give away his money to himself like that.
So I do want to correct something I just said, and somebody pointed it out. It said we're showing 2 and 4. The 2 color, if you look, we're selling the old inventory. We're selling off the inventory of the old 2 colors.
Okay.
So there's probably 30 units left or something like that. So yeah, that's the old 2 color system. Right? I think it says it too. It says it's close out. So
yeah. So thank you, Bill, for coming on. It's been interesting. I've learned that that all the changes you've made, and it's good that we got a bit of a preview of what's coming up. You were kind of gang Preston to give them a little bit of information, but it's okay.
That's all right.
But thank you guys. Thank you for coming along, and thank you also to Loyal for sponsoring the giveaway. It was
yes, sir. Thank you.
On the spur of the moment, it was great. Thank you so much. And I'm just going to pop out. If you guys hold on a moment, I'm just going to pop out, do my closing, and I'll be with you in a moment.
Thanks, everybody.
Thank you. So that was a interesting evening. It was a great talk. I think we actually went through the G code. We talked about the abilities of the functionality that you can actually go up to 32 or more, or 32, I believe, is a cap at the moment. Extruder, so it's really fantastic. Really special thanks to Bill and to Loyal for this evening. Loyal for the giveaway and Bill for being our guest tonight. So remember, like, subscribe, ding that bell. I do every Thursday night. I do a stream like this, an interview stream. Next week, I'm actually going to be interviewing someone from Wido, the 3D printing manufacturer in China. So I'll have someone on from Wido. We're going to have a talk with them. And then the week after that, which is the following Thursday, which is Thursday let me double check my calendar. The 4th, I'm actually going to have Lulz. So we're going to have the president of Lulzbot coming on to do a talk about Lulzbot and what's happening with that company as well. So please like and subscribe and ding that bell so you get notified of my future streams. And also every Wednesday at 7 p.m. I do hangouts, and everybody's welcome to come hang out at my hangouts. Now, if you want to help support the page, please the liking and subscribing helps promote me on YouTube. You can also donate if you want to donate to the channel via PayPal. You can click on that and go to that link and donate. Or if you just want to buy me a coffee, you can also do that. Just keep me caffeinated so I can keep going and keep this content coming out to you. And with that, I'd like to thank you and I hope you have a good evening. And remember, stay safe, stay healthy, and stay printing. Thank you and have a good evening.